Abhar Patera, can you hear me? Abhar, can you hear me? Parin, can you hear me?
Yes, ma'am.
Yes, ma'am.
Good morning, all of you. I told you when we dip a chalk in red ink, red color will be adsorbed on the surface of the chalk, but the chalk will be wet from inside. So here, adsorption and absorption both take place. In such case, we call it as sorption. What is adsorption? Accumulation of molecular species on the surface rather than the bulk is termed adsorption. And the material on which adsorption takes place is called adsorbent. And the substance which gets adsorbed on the surface is called adsorbate. So chalk is the adsorbent and red color is the adsorbate. When we mix animal charcoal with a raw sugar solution, animal charcoal is the adsorbent, animal charcoal is the adsorbent, and the color, that is the adsorbate. If adsorption and absorption both are taking place simultaneously, then we call it as sorption. Now, what is the mechanism? What is the mechanism of adsorption? Why the things are getting adsorbed on a surface? Some clothes, if you keep in the cupboard for a longer time, the gas molecules get adsorbed on the cloth and the cloth smells bad. And if you put in the sunlight, then these adsorbed particles will be getting away. So that is called a dispersion. What is adsorption? Accumulation of molecular species on the surface rather than the bulk is termed as adsorption. The removal or the getting away of this adsorbed particles, that is called dispersion. Dispersion. Now, what is the mechanism of adsorption? Consider the surface. A molecule in the interior is attracted. A molecule in the interior is attracted. Suppose this is a molecule. It is attracted in all directions by the same kind of molecules. So the forces are getting mutually cancelled. Force of attraction between any molecule. Consider a molecule which is at the top on the surface. It is attracted by more number of molecules towards the interior portion, but only less number of molecules outside. It is attracted by more number of molecules here inside. Why? Only less number of molecules up. That means there is a residual attractive force acting towards interior. Residual attractive forces. These residual attractive forces, means that is a receptor force. These residual attractive forces attract the adsorbate from top to the surface, and there was some residual force of attraction and the surface was under tension. That is called surface tension. Surface was under tension. Now, when the adsorbate molecules adsorb on the surface, tension is released, that means some amount of energy is released. That is released as surface energy. That is surface energy. So there is residual attractive force. Why? Because more number of molecules in the interior portion compared to less number of molecules outside. There is residual attractive force. These residual attractive forces attract the adsorbate molecules on the surface, and surface energy is released in the form of heat. That is called heat of adsorption. Heat of adsorption. That means the release energy means that delta is equal to delta is having a negative value. We know that for a process to be spontaneous, delta G should have a negative value. Delta G is equal to delta H minus E delta S. Now, you know, adsorption is a spontaneous process. It takes place on its own. You don't have to force anyone, right? So, delta G should have a negative value ultimately, and we know that delta H is negative. What about temperature? At any temperature, adsorption takes place at any temperature. Physical adsorption takes place at lower temperature. When the temperature is more, the adsorbed particles get dissolved. That is what has happened when we spread the cloth in sunlight or in the sun. As the temperature increases, the adsorbed particles get dissolved. So delta H is negative here. What about delta S? Delta S at constant temperature. Let T be constant. There is no delta. So delta S. What is the change in entropy? The particles are getting adsorbed. That means they are coming from a random motion to a stable. If it is settled down, that means the freedom of movement of the particle, adsorbate particle, becomes less. That means delta S is having a negative value. Delta S is having a negative value because the freedom of movement is less. So here, this is negative, means negative into negative positive. For delta G to be negative, then delta H should have a high negative value. Question is spontaneous. Delta H will be having a high negative value. What is delta H? That is the enthalpy of adsorption. There is a heat energy released when the adsorbent particles get adsorbed to the surface. So, as the adsorption continues, you know that tension is decrease, right? So, as the adsorption continues, this delta X value becomes less negative. It becomes less negative, and when it becomes equal to the magnitude of T delta S, delta G becomes 0. That is, the process comes to an equilibrium. This is positive and this is high negative. This is positive because delta S is negative, positive. So that portion becomes positive in the case of adsorption. And delta H is having a high negative, so that delta G will be having a negative value. So as the adsorption continues, in the beginning the amount of energy released will be higher. So the magnitude of this delta H will be higher. As the time passes, as the adsorption continues, this value becomes lesser and when it becomes equal to the magnitude of T delta S, delta G becomes 0. One is negative, one is positive. The beginning, This value of magnitude was higher. Magnitude was higher. As the adsorption continues, this magnitude gets lower and lower, and when it becomes equal to this negative value becomes equal to the positive value, delta G becomes 0. That means it becomes to an equilibrium. Further adsorbs, then you will not see any change. Equilibrium starts, means equilibrium starts means then you will not find any change. There is a mechanism of adsorption. Adsorption is exothermic. Why? Surface energy is released. There was tension, surface tension before. When these molecules get adsorbed, surface energy is released. The tension is released. So, adsorption is an exothermic process. Now, there are two types of adsorption based on the forces of attraction between the absorber and absorbate. What are these types of adsorption based on the force of attraction? One is called physisorption and the other is called chemisorption. If there is only van der Waals force of attraction between adsorbate and adsorbent, then we call it as physisorption. Or if the force of attraction is a chemical bond between adsorbate and adsorbent, then we call it as chemisorption. What are the differences between physisorption and chemisorption? Physisorption, the force of attraction is van der Waals force of attraction. But in chemisorption, between this adsorbent and adsorbate, the force of attraction is chemical. In the case of physisorption, the enthalpy of adsorption is very low, 20 to 40. Enthalpy of adsorption. Enthalpy of adsorption is 20 to 40 kilojoules per mole. Amount of energy released. But in the case of chemical bond, much more greater force of attraction, so more amount of energy will be. So, 8. Now, physisorption, it is reversible while chemisorption is irreversible. Physisorption, the molecules are getting adsorbed or heating, or as the temperature increases, the molecules get away. That means it is reversible. But chemisorption is irreversible. Why? Because the chemical bond is formed between the adsorbate and adsorbent. Therefore, specific or non-specific. Any adsorbent molecule can be adsorbed on the adsorbent in the case of physisorption, but only those molecules which are a chemical bond will be adsorbed in chemisorption. So this is not specific. This is specific. Next is activation energy. In physisorption, no need of activation energy, but in chemisorption, since a chemical reaction is taking place, you have to give activation energy. In most cases, you have to give, most of the cases, you have to give activation energy. No activation energy. And here, activation energy means you may have to heat. Temperature. Physisorption takes place at lower temperature, while chemisorption takes place at higher temperature. When the temperature is high, what happens? The adsorbed particles will get away. When the temperature is high, dissociation will be taking place. In physics-ocean, there will be multi-molecular layers. Multi-molecular layers. While in chemistry-ocean, only unimolecular layers. Surface area in both the cases, as the surface area increases, adsorption increases. This is surface versus surface phenomenon. It is surface phenomenon. So, as surface area increases, in both the cases, adsorption increases. And easily liquefiable gases will get adsorbed easily. Easily liquefiable gases means whose critical temperature is very high. For example, sulfur dioxide critical temperature is 630. So, you can expect SO2 till 630 degrees Celsius. That means SO2 is more easily liquefiable than you can say other gases like ammonia. Ammonia is also liquefiable. Sulfur dioxide is very highly, easily liquefiable. Easily liquefiable gases will get adsorbed easily. Gases can be adsorbed on the solid surface. On heating, the adsorbed gases will get away. As the temperature increases, what happens? The adsorbed particles will get away. Now let's move to adsorption of gases on solids. Adsorption of gases on solids. Suppose some amount of gas got adsorbed on solid. If you know the weight of the solid and weight of the adsorbed gases, so before adsorption you take the weight of the solid, and after adsorption you take the weight of this that material on which adsorption has been taken place. So you can get the amount of adsorbed weight also. If M is the amount of adsorbed weight and X is the amount of adsorbent, M is the amount of adsorbed weight. M is the amount of adsorbed weight and X is the amount of adsorbed weight and M is the amount of adsorbent. Then X by M is the extent of adsorption. X by M. On M, how much X? On M, how much X? Or from 1 gram of M. What is the adsorption? M is in the denominator. M is the mass of the adsorbent. Mass of the adsorbate. You have to specify what is the amount. If you are writing this for M, then you have to specify what you have taken. X is the amount of adsorbed weight and M is the mass of the adsorbent. Then X by M is the extent of adsorption. This is adsorption of gases. So, as the pressure increases, suppose you have taken an adsorbent and on that you put the gas. If you apply the pressure on the gas, then more and more gas will be colliding this adsorbent and it will get adsorbed. So, as the pressure increases, adsorption increases. As the pressure on the gas increases, more and more molecules will be touching this adsorbent and the adsorption increases. A scientist, Freundlich gave a relation between the pressure and the extent of adsorption. He gave the relation as H by V K 1 by H and 1 by X brings 0 and 5. If you plot a graph between this H by M and pressure. As the pressure increases, exertion increases. As the pressure on the gas increases, exertion increases. So the graph is having this. The graph is having see, as the pressure increases, exertion is increasing. As the pressure increases, exertion is increasing. And here it becomes you see 1 by n can vary but if 1 by n is equal to 0, that means exertion is independent of the pressure. See, as the pressure increases, exertion is independent of pressure. This is here 1 by n. Now 1 by n is equal to 1. That means exertion is increasing as the pressure increases, exertion is linearly. That means this right? It is increasing linearly. That is here 1 by n. So here in between, that is between this is 0, this is 1. So in between 1 by n will be having any value, right? This area 1 by n can have any value. So this is the relation given by Freundlich and we call it as Freundlich exertion isotherm. How can you verify that Freundlich exertion isotherm? For that, I will take a log value of this. That means log x by m is equal to log a plus log 1 by m log b. This is general format. So log x by m is equal to log a plus 1 by m log b. I am writing in this format of 1 x y is equal to mx plus y is equal to mx plus c. If you plot log b on x-axis and log x by m on y-axis, you will be getting a straight line with a y-intercept log a. If you are getting a straight line by plotting these things, that shows that Freundlich exertion isotherm is verified. So, here I am taking log p and here log x by m. If you are getting a straight line, log p you mark with the log x by m, you will be getting some points. If you join those points and if you are getting a straight line, that shows that Freundlich exertion isotherm is verified. And this y-intercept will give you the value of log p. Alright, and 1 by m, that is a slope, you can take this y by x. Slope is equal to 1 by m. So from there you can calculate n value, find out the slope, that will give you 1 by m. So what is Freundlich exertion isotherm? Isotherm, that is at a constant temperature. For Freundlich exertion isotherm, I showed you the graph. That graph is called the isotherm. Pressure and x by m. This is at lower temperature. As the temperature is high, it's a constant temperature. At a particular temperature, this is called this graph, that is called isotherm. Constant temperature, so we call it as isotherm. When you increase the temperature, absorption decreases. Even T2 is greater than T1. But T2 is greater than T2 is greater than. If you again increase the temperature, and suppose at a higher temperature you are doing this measurement of P and X by M and you are plotting a graph. T3, as the temperature increases, for example, I can write 191, 215, 235 degrees Celsius. If you increase the temperature, adsorption decreases. Each one is called an isotherm. Each one is called an isotherm because each one is measured at constant temperature. So that's about Freundlich's adsorption isotherm. This is for gas adsorbed on solids. Gas, adsorption of gases. Adsorption of gas on solid. That's a reversible process. The equation we can write like this: solid plus gas. Gas or solid. Gas or solid. And what happens? Some heat energy is released. That is the enthalpy of adsorption. Suppose you give heat to this. Suppose you heat this. What will happen? This will absorb that heat and backward process will be taking place. That means on increasing heat, the system will adjust itself to nullify the effect of the change. If you increase the heat, this will absorb that heat, this will take that heat and it will move to solid plus gas. That means dissorption takes place. So dissorption will be on increasing temperature, adsorption decreases. Now I told you as temperature increases, chemi-sorption increases. As temperature increases, chemi-sorption increases because when you heat, chemical reactions becomes faster. Chemical reaction becomes faster. But this is till to a particular temperature. After that, if you again increase the temperature, then the chemi-sorption particle will get away. That means, in the case of chemi-sorption, in the beginning, as temperature increases, adsorption increases, and afterwards, adsorption decreases. In chemi-sorption, as the temperature increases, as the temperature increases, adsorption increases and it reaches to a maximum point and then decreases. So as the temperature increases, adsorption increases and then decreases. Next, adsorption from solution. Adsorption from solution is similar to the gases. Approximately, it is same as that of the gases only. Again, here also, Freundlich's adsorption isotherm can be approximately written in the form of x by m is equal to k c to the power 1 by m, where c is the conservation. In the case of gases, conservation we talk in terms of pressure. For solution, we talk in terms of conservation. For gases, what is meant by conservation? It's pressure. For solution, concentration means the real concentration, polarity. Okay, again, this is similar to that gases only. As the concentration increases, adsorption increases. As the concentration increases, when you put little bit of jala in water containing little charcoal, right? What happens? Take the jala solution, jala in water, so you got the jala solution, and in that you put little animal charcoal. So from solution, the charcoal will be absorbing. This Ujala solution, charcoal will be absorbing that. So that depends on the concentration of that solution. So this is similar to that xy is equal to kp c to the power 1 by m. Here, as the temperature increases, adsorption decreases. As the concentration increases, adsorption increases. These are the factors. Adsorption from solution. Now, what are the applications of adsorption? To create high vacuum, you must have seen vacuum packed this acrobat and walnut, that is uproot. Vacuum packing you must have seen. For this, mainly we see for uproot only, this walnut. To create that vacuum packing, then in gas mask, charcoal, finely powdered charcoal is kept to absorb the poisonous gases. Means it will be acting like a filter. What we are using this N95 and N99 masks to filter that, to make adsorption. Then what for flotation process? For flotation process, lighter ores, sulfide ores, lighter sulfide ores are adsorbed on that fruit, jam, that is based on adsorption. Sugar solution is cleared, or decolorization of the sugar solution by animal charcoal is another example for adsorption. Then chromatography. In chromatography also the technique used is adsorption. Okay, these are the applications of adsorption. And you know, some catalysts. Sponge iron is used for the preparation of ammonia from nitrogen and hydrogen. So it is acting as a catalyst based on the adsorption only. This is used as the catalyst. And then contact process for the preparation of sulfuric acid, vanadium pentoxide is used as a catalyst, again based on the adsorption. Okay, thank you.